In this video, we present RelEx, a system for visualizing in-car specification data. RelEx is a careful combination of traditional domain representations enriched with novel visualization and interaction techniques. The electronic control units, or ECUs for short, are the nodes of a physical network, with bus systems being the edges. On top of that, we find the signal specification, in which engineers define which signals will later on be exchanged between which pair of ECUs. For this video, we use an anonymized dataset with 93 ECUs, 9 buses, and roughly 8,000 signals. RelEx supports automotive engineers who are involved in this specification process. It specifically aims for improving their data exploration capabilities during the implementation of change requests from other engineers and network optimization tasks. Let's consider some examples. Our target user Tom, for instance, gets a change request that the TMM ECU needs to receive a certain signal. First, he verifies that the signal is not already received by this ECU by looking up the signal in the signal list. From the list, he indeed sees that the TMM ECU is not receiving this signal. He clicks on the signal, which highlights all sending and receiving ECUs, as well as bus systems which transport this signal in all other views. By looking at the topology map, an interactive version of a domain-specific representation, he instantly notices that the signal is available on the ACAN bus that the TMM ECU is connected to and replies that he can easily implement this change request. Another colleague of Tom asks him which of two ECUs he should implement major changes to, the AFR ECU or the MSE ECU. Tom knows that both are connected to the gray BCAN bus and selects both by holding the Shift key. As the decision strongly depends on how many signals, ECUs, and buses might be affected, he turns to the matrix view, which gives an overview over signals that are exchanged between ECUs. The sending ECUs are at the top and the receiving ECUs on the left. The size of the boxes indicates how many signals are exchanged between a pair of ECUs. He sees that while the AFR is a global communicator with many signals to and from other ECUs, the MSE has comparably little. He also sorts the matrix by bus connectivity. By inspecting the bus squares that are not on the diagonal, he sees that the AFR ECU is involved in a lot of cross-bus communication, while most of MSE's communication remains within the same bus subsystem. He therefore recommends to change the MSE, not the AFR, ECU, and uses RelEx for communicating his findings. Another engineer, Franz, is strongly involved in network optimization endeavors. Today, he is interested in verifying that cross-bus communication is minimal. To do so, he refers to the bus-sorted matrix view and looks for communication hotspots. The thick black outlines showing communication of more than 100 signals allows him to quickly identify hotspots. He is pleased to see that all of these are within bus subsystems and continues to look for large cross-bus communication boxes that are not on the diagonal. By clicking on one of them and following the crossbeam to its receiver, he notices that this ECU seems not to have any inter-bus communication at all. Astounded, he selects this ECU by following the blue sender and the red receiver crossbeams and finds that it is a receive-only ECU. He also notices that although it is connected to 3 bus subsystems, all incoming information comes from a 4th bus, FlexRay, that this ECU is not directly connected to. He also checks some of the sent signals and finds that their signal paths all go over the ABU gateway ECU. He now considers connecting this ECU directly to the FlexRay bus and deleting all other bus connections, but remembers that the physical position of this ECU in the car would not allow that. He therefore decides to change the specification by disconnecting the ECU from 2 of the 3 buses and routing all communication over the remaining bus. In doing so, he will save bandwidth on the other two buses and cable costs. RelEx provides many other features such as flexible window management, magnifying the matrix view, or locally changing the network. More information about the data and task abstractions, the design of RelEx, examples of how engineers used it, and its adoption can be found in the paper.